G'day everybody, where's Wally here? Well, I guess I was using too many facts for poor Mitch to handle, because as soon as the Patreon pledge was paid, he found an excuse to ban me. Well, we all knew this would happen, and in fact a few of us, we ran a sweep to see who could guess the ban time. Well, my video went out on November the 1st around 3 AM, and then I was banned a mere 30 hours later on the 2nd. Good job, Mitchell, good job. I've been working on simplifying the Ubersextant's proof of R anyway. Seems flatties see a curved line and take fright and claim begging the question. I think you'll find that the curve takes no part in the proof whatsoever, so it's totally irrelevant. That means, Mitch, you did the fallacy. That's where you toss as many formal fallacies at the wall to see what sticks.
Thanks for confirming that, Wally. Massive begging the question fallacies there. No, there's another fallacy, false dichotomy. It could be either globe or flat. Yeah, false they're just full of fallacies. What a generic fallacy right there.
But you're wrong. I've even had some hardcore Muppets claim that I was wrong because I said that I was within 2% of the accepted value of R. They just don't get it, do they? Anyway, without any more of the Mitch pokery, here is the R proof yet again for Mitchell and his mates. On September 24, 2021, I hired a telescope in Dubbo, Australia. Wolfie was in Sydney also, and he got out his good telescope that night too. We pointed them both at a group of geostationary satellites over the equator, well, naturally, and their GPS are roughly 0 and 109.8666 longitude. Geostationary satellites, did I say? I sure did. Well, that's 3 Bitcoin right there, but I'm not claiming those yet. Well, both telescopes observed this group of eclipsing satellites in turn as they entered the Earth shadow, as this was midnight 2 days after the equinox. Oh, that's Bitcoins 4, 5 and 6 right there. So these satellites, they reappeared exactly 1 hour, 7 minutes and 34 seconds later. Fun fact, each time we measured the length of the eclipsing, we got a different value. I guess the tilt of the Earth explains that. Bitcoins 7, 8 and 9 right there, Mitch. Enough of the Scrooge McDucking. On with the proof of R. So taking the frame from both Ubersextants at exactly the moment when the satellites entered the shadow at 1:58:08 AM local time, I was able to get simultaneous sightings of the same satellite from 2 different locations. Fact A, the 2 Ubersextants were measured on Google Maps to be 281.91 kilometers apart. That's not disputable. Fact B, you can see the same grouping of satellites and you can even see the same stars passing behind them, although there is parallax there, obviously. I'm not sure if that's Bitcoin worthy. I'll let that one slide. Fact C, taken at the same time as you can see the geosats go dark in both telescopes, so we know that it's the same time. And the timestamps from both telescopes are within a few seconds as well. Fact D, the pointing data from each telescope is given, the azimuths and the alignments are all within 1 degree, so we can pretty much ignore those and treat this as a 2D problem and use Muppet View to explain this proof. Fact E, I used plate solving to verify the telescope pointing angles as well. Plate solving is sort of astronomical almanac, if you will, and it's super cool. The difference between the right ascension values also tell me the angle between the 2 lines of sight is just 0.074 degrees. The 2 elevation values are how far above the horizontal plane the sight lines are. This horizontal is derived from the stars themselves, and it's amazingly accurate, and it matches the local horizontal precisely. I also noticed that the Sydney image was not quite centered on the frame like the Dubbo image was, and by counting pixels I worked out that it was 0.2570 degrees of frame shift, which I corrected for. Now this image here on the screen is only the measured facts, so what does all this mean? Well, I added the difference in the elevations to the frame shift correction and the difference in the right ascension values, and it seems that the level in Dubbo is 2.5979 degrees different to the level in Sydney. If the horizontal planes are not coplanar, then the verticals cannot be parallel. And if they're not parallel, then they might just converge. So the verticals at Dubbo and Sydney are 281.91 kilometres apart at the uber sextants. They diverge upwards, so they must be converging downwards. So now we have an isosceles triangle with a base of 281.91 kilometres and the acute angle of just 2.5979 degrees. It is simple maths to solve that, just to work out that the two large angles, which are the same and are 88.701 degrees. Now a little bit of law of sines and voila, the length of the two sides of the telescopes to where the verticals converge. Now that we have a point of convergence, you want to buy a vowel? Only costs 3 Bitcoin. So I measured the R as 6218 kilometres or 3684 miles. Now that's just 2.5% from the accepted value. Not bad at all. Over to you, Mitchell. Excuse away, old chap. P.S. Mr. Sensible's not wrong.
P.S. Mitch, when you are using a sextant for celestial navigation, you're not triangulating your position.
Bow. That is a massive, massive error on your part, Mr. Sensible.
Who feels silly, Mitch? You do, don't you?
Thanks for confirming that, Wally.